All right, so let's go over the check your understanding for today. It says gapminder.org is an organization dedicated to studying global health. Here's a scatter plot showing the average annual income in thousands of US dollars and life expectancy in years for a random sample of 15 countries selected from the Gapminder database. The output shows three possible models for predicting life expectancy from income. Model A is based on the original data. Model B and C involve transformations of the original data. Each set of output includes a scatter plot with least squares regression line added and a residual plot. The regression equations are given below. Okay, so here's our model A, B, and C. We can see in model A that we have a fairly linear pattern, but in our residual plot, we see kind of more of a leftover pattern. We come up and then we come back down. Okay. In model B, our transformation is that we're taking the natural log of the predicted life expectancy. The resulting scatter plot looks very similar to model A, although it's slightly more linear, but I still see in my residual plot that leftover pattern. And then in model C, we're taking both the natural log of the predicted life expectancy and the natural log of the income. So we're doing it twice instead of just the once, or taking the natural log of both the X and the Y axis. When we do that, we can see we really do get much more of a linear pattern, and our residual plot is very scattered. Let's look at what we're asked to do in part A. Or in part 1, it says use each model to predict the life expectancy of residents of a country for which the average annual income is $80,000. So for model A, we have our predicted life expectancy. Can't spell today. Is equal to 69.9352 plus 0.1530 times the income, which we're calculating at $80,000. And so when we put that into the calculator, we get 82.18 years. Okay. For model B, we have the natural log of, I'm just going to put LE, life expectancy, is equal to 4.2436 plus 0.0021 times our $80,000. And it's important to note here that what we're equal to is the natural log of the life expectancy. So the answer I get when I put this, the 4.24 plus 0.0021 times 80,000 into my calculator is 4.4116. But I need to convert this into just the predicted life expectancy, not the natural log of the life expectancy. So to find just the predicted log of the life expectancy, I need to take and do e to the 4.4116, and I get a life expectancy, the predicted life expectancy of 82.40 years. And then for part C, I have, again, the natural log of the predicted life expectancy equals 4.1393 plus 0.0603 times the natural log of 80,000. And so I can put all of this directly into my calculator to get 4.4035. And just like before, it was equal to the natural log of the predicted life expectancy. To find just the predicted life expectancy, I need to do e to the 4.4035, which comes out to be 81.74 years. So very slight changes in the amount of years, but ultimately giving us a different answer. Part 2 asks us which model does the best job summarizing the relationship between income and life expectancy. So remember, our criteria for choosing the best regression model are to check the scatter plot for a linear pattern, check the residual plot for no leftover pattern, and check that the R-squared value is closest to 1. So we don't have the R-squared value, but we talked about how in model C, we have the most linear data and our residual plot has no leftover pattern. So our best answer is going to be model C. I'm going to say the scatter plot is the most linear and the residual plot has no clear curved pattern, or you could say no leftover pattern, either one. All right, if you have more questions, as always, make sure you ask them in class.